Look at this sample of nanocubes I made. I have to keep in this bottle or else
Caden uses the Schlenk lens, so I use the Schlenk lens.
Caden uses the base lens. I
Caden does electrochemistry, so I do electrochemistry.
Caden reads papers about nanocatalysts, so I read papers about nanocatalysts.
Hi, my name is Caden, and I'm in the least walkable borough of New York City, Staten Island. Look at all those cars. That's a lot of carbon emissions. Anyway, here's my ride.
Get it, loser, we're going shopping.
Who am I here with today?
Janetta.
Daniel Olshansky.
You're here with Chi-Chi. Tiffany.
Kaylin.
Speeds up the reaction.
A catalyst is, let's say, a substance that does not get changed in a reaction and helps lower the activation energy. And an example would be lactase, I think.
I know catalysts like speed up chemical reactions.
Nothing.
You speed up chemical reactions.
They help speed up chemical reactions.
Catalysts, as you may have learned in your high school chemistry class, lower the energy barrier required for a reaction to take place. Catalysts, as you may have also learned, do not get used up or consumed during a chemical reaction. But in reality, this is not completely true. Some of them can get poisoned or become catalytically inactive because of a reaction. Take your car, for example. The catalytic converter inside converts toxic gases like carbon monoxides and nitrogen oxides into less chemical, more inert gases. The noble metals inside your catalytic converter, however, start to get poisoned by carbon monoxide and have to be changed every 7 to 9 years or so. This is why we investigated transition metal selenides, because of these flaws in noble metals. In particular, we're looking for one that's stable, has a high selectivity, high efficiency, and doesn't require too much voltage to operate.
Because nano is faster.
I think it could help, let's say, like enzymes and substrates bind in more ideal shape configurations to increase the efficiency of reactions and stuff like that. And maybe nanotechnology can, I don't know, provide some assistance in that field.
I think it's like kind of the basis of everything, like atoms and understanding how they work. So I think it's a really important field to research. Maybe if it helps speed up chemical reactions on a nano level, it's like a chain reaction to speed up the overall process on a larger level.
Because they could work as catalysts because they're small enough to put the molecules together.
Why nanocatalysts? On the nano level, that's where classical physics doesn't apply and quantum mechanics takes over. Electrical, optic, and magnetic properties are completely different on this smaller scale compared to their bulk counterparts. In addition, on the nanoscale, we can make different structures like nanosheets and nanocubes. Testing nickel selenide and copper selenide, we found that one, nickel selenide has good ferritic efficiency at creating ethylene glycol, while copper selenide is pretty good at making gaseous products.
Through these experiments, we found pretty high yielding and selective carbon dioxide reduction catalysts. However, they aren't without their flaws. Problems that still plague these catalysts include high overpotentials and struggles of scaling these up. But hopefully our research brings us closer to a world where we can capture carbon dioxide and turn them into useful products.